What's up, my mathletes? This is section 3.7, Quadratic Inequalities, and this is the first time we're seeing we've seen linear inequalities before, and we've graphed those and shaded those on the number lines, but this is the first time it's going to be quadratic, so check this out. We've got, if we're going to be graphing, boom, then we need equation table graph, and I'm not going to make you do it by hand here in the notes because we've done a ton of those, and you know how to do it. You know that the first step would have to be to find the middle row, where the vertex would be. That's going to be used, that you're going to use h equals negative b over 2a for each, and then graph. So here, a is 1, b is 6, c is 4. So negative b over 2a would be negative 6 over 2 times 1, which is negative 3. If negative 3 is the input, then negative 5 is the output. And you can construct a whole table, negative 1, negative 2, negative 3, negative 4, negative 5 as all the inputs. You get all the outputs, and then you graph them. And then you plot those points, and here they are. You can see. Go ahead and copy this down, the graph, and really you notice that here, notice here, let me move my head. You can see on the graph we've got a solid line, and that's because this symbol right here is solid, as you might expect. This symbol is a less than or equal to, as you might expect. So then, therefore, we graph with a solid line. Over here it's going to be different with a dotted line or a dotted curve. And then, how do we know which way to shade? Do we shade in the middle over here? We shade outside of the parabola. And really, the best way to do it, I think, is take a test point. 0, 0 is right here, and it's the easiest number you can have to plug into both x and y. So the question is 0 less than or equal to 0 squared plus 6 times 0 plus 4? And yes, it is, because this is a true statement. 0, 0 is a solution of the inequality, and if it's a solution of the inequality, then so are all the other people in its neighborhood. So boom, there you can shade in everything on this side of the parabola. Yay! Let's do the same thing again here. A is negative 1, B is 4, C is negative 6. I'm not going to make you copy all the table. You've done plenty of those. Thank you for all the hard work you've done. You don't have to do it again. And so you can take all these input and output values. Oh, sorry. Negative b over 2 times a would be this, and when you calculate it all out, you get 2. And if 2 is the input, then negative 2 is the output, and you can see 2 comma negative 2 is where the vertex is, and all the other points help us graph the parabola. You can see that it is a dotted parabola, dotted curve, because this symbol is just a less than symbol. And how do we know where to shade? Well, you take a test point 0, 0, for example. It's the easiest number to put in, so you don't have to do 0, 0. In fact, sometimes if the parabola is directly on the point 0, 0, then you need to find a test point that's off the parabola. But in this case, it's easy enough to plug in. We get 0 is less than or equal to negative 6, which is a false statement. So don't shade in 0, 0, and don't shade any of its neighbors either in its immediate region. Shade in the other part right over here. A is 1, b is 0, c is negative 4, so negative b over 2a is going to be 0. And so 0 is here, and you can take some numbers on either side, and you get these points to plot, as you can see right here. This is going to be solid because of the symbol greater than or equal to, so that's how we indicate that the boundary line is also part of the solution set. And take 0, 0 and plug it in, and you get a true statement. So therefore, you shade in 0, 0 and all of its neighbors in its region. Big ideas here would be solid lines indicate less than or equal to symbol and greater than or equal to symbol, and dotted lines or dotted curves indicate less than and greater than. And when deciding where to shade, just take a test point and then shade accordingly. Now, here's a little review. This is what we know from Algebra 1 and what we've seen already before in previous chapters. If you're going to do this, you can use your Algebra 1 skills to undo the addition, undo the multiplication, and remember, when you divide both sides by a negative number, you get x is less than 2, so you shade in this direction, where this is negative 2. We're going to leave this as an open dot because of the symbol. Negative 2 is actually not a solution, but everything to the left of it is. Again, here you can you can actually subtract 5 from both sides, and then you can divide both sides by negative 4. Again, flip the sign. You get x is greater than or equal to negative 4, and then you can shade in this direction to the right. you can see this little arrow right here. Boom! It's also the same size and shape as not the same. It's pointing in the same direction as this. That's one way that students remember how to shade. Anyway, all these numbers and including -4 are solutions because of the symbol and the dot. Here you can undo the division by multiplying. You can undo the subtraction by adding, and you get x is less than 3. So all these numbers are less than 3, and they all work, but 3 does not, so we're going to leave it open because of the symbol. Now, that's a review, and I'm glad we did it because we're going to use some of those skills, but in other ways, anything more complex than a linear inequality, you just got to completely abandon because it's the skills you've learned before are not going to help. What we've got to do for something more complex is that we've so for example, if it's x squared here, it's just x to the first power, but here it's x squared, and things are going to get way more complicated. And from here on out, we need more robust techniques for handling this kind of thing. So let's check this out. Let's see. We've got here we've developed all these techniques for solving equations, so that's what we're going to use. And in fact, the first thing we've got to do is convert this inequality to an equation. And once it's an equation, we've got a whole bunch. We spent all of Chapter 3 talking about how to solve quadratic equations, so we can apply those here. I'm going to split the middle, and we get the, give me a factor pair that multiplies up to -32 and adds up to 4, positive 4. It's going to be positive 8 and -4. So we're going to write this here, splitting the middle. Greatest common factor over here, greatest common factor over here. And so therefore we get two different x plus 8s, and we can factor them both out and get x plus 8, and then what's left is x and a -4. So therefore the solutions are going to be positive 4 and -8. Here's what we do with that information. Welcome folks, this is what's called a sign chart, and you've never seen this before, but you're going to start to see a lot of them. Let's walk through it slowly. This up here, the top row, is what's indicating, it's basically the x-axis. It's going to be it's a shorthand version of what's representing the number line here. You have negative infinity, all the way down to negative infinity, and then it's going to stop here at -8. You're going to put your, excuse me, you're going to put your solutions here, -8 and 4, and they've got to be in order. The lowest number is -8, and the highest number is 4, because we're basically splitting up the region, the number line, into these different regions. We want to examine, should we shade in, I'll show you what it looks like. Here's the final version. The question is, should we be shading in all the stuff that's less than -8? I don't know. Should we be shading in the stuff that's in the middle here, in between -8 and 4? I don't know. Should we be shading in the stuff that's to the right of 4? I don't know. But so that those are the three different regions we have to indicate, or we have to decide on. The two solutions, -8 and 4, divide the number line into three different parts. We need to examine all three of them separately. So, and because we have this factored into x minus 4 and x plus 8, we're going to examine them individually. X minus 4. So here, let's taking a test point like -10 that's in this region that's less than -8. Well, this region here is negative, so we put a minus right here. Like if you take -10 and put it into x minus 4, -10 minus 4 is -14, and that's definitely negative. What about over here? All the numbers in between -8 and 4, that would be like 0, for example. 0 minus 4 is negative, so we're going to indicate that it's just negative here. This is called a sign chart because all we really care about are the signs of this inequality, the signs of these three different regions. When you're at 4, that's going to be 4 minus 4, which is actually 0. And when you're higher than 4, like 10 or 100, 100 minus 4 is 96, and that's positive. So this region is negative, this region is negative, and this region is positive, and this is where 0 is. Let's do that again for the other factor, x plus 8. So x plus 8, if you look in this region, like at -10, -10 plus 8 is still negative, but if you're looking at -8, -8 plus 8 is actually 0. That's where the 0 is. And anything higher than negative 8 is going to be positive, like 0 here. If x is 0, then 0 plus 8 is also positive. And then over here, 4, if you do 4, 4 plus 8 is still positive, and this is still positive. 100 plus 8 is 108, and that's still positive, all the way up to positive infinity. So now we've examined x minus 4 and we've examined x plus 8 separately. Now if we multiply them together, we get x minus 4 times x minus 8. Well, the sign chart here is more complex, but because we've done so much thorough preliminary work, we can just say that all these, this is negative and this is negative, so when their product is going to be positive. A negative times a negative is a positive. A negative times a positive is a negative. 0 times anything is 0. 0 times anything is 0. And a positive times a positive is a positive. And so we can see here that this region is going to go positive, negative, positive. And so here, boom, positive, negative, positive. That's we're shading these in because we really want to know when is this greater than or equal to 0. Well, it's greater than or equal to 0 here, so it's shaded in. It's not greater than or equal to 0 here, so it's not shaded in. And it is greater than or equal to 0 here, so yes, let's shade it in. This is how we take a sign chart, we turn it into something like this. You might think that sign charts are there's like a lot of handwriting going on here, and there's a lot of stuff that you'd have to examine, and maybe there's an easier, faster way, and maybe the savvy student might be able to show you. But in calculus, when you get in 2 years from now, and a little bit in pre-calculus, you're going to live, breathe, and die by your sign charts. So I figured we might as well introduce them early and practice them well. Let's also remember that the solid dots, just like before, solid dots indicate that 4 and negative 8 are actually solutions. Like 0 would be greater than or equal to 0. So we fill them in to indicate that negative 8 and 4 are actual solutions to the inequality. Check out what's going on here. X squared minus x minus 6 less than 0. Well, let's, as before, let's turn it into an equation first and solve it. We're great at solving equations. We've got so many tools. I'm going to split the middle again because factor pairs that multiply up to negative 6 and add up to negative 1, that's negative 3 and positive 2. So x squared minus 3x plus 2x minus 6 is equal to 0. I'm going to factor out the greatest common factor here. X times parentheses x minus 3 plus 2 times x minus 3. And look, we get x minus 3 gets repeated twice. So therefore, we are going to factor out the x minus 3, and that's what we get, and then x plus 2 here is equal to 0. And so the solutions are going to be 3 and negative 2, because those are the numbers that make it equal to work. So 3 and negative 2 are also the numbers we're going to head with our sign chart. And eventually, just to give you a heads up, there's 3 and negative 2 are going to be the numbers that go on our number line as well. They divide the number line into 3 different regions. These 2 solutions divide them into 3 regions. Everything that's less than negative 2, everything that's in between the 2 solutions, and everything that's after positive 3. Knowing that we can also multiply factor these into 2 different parts, let's examine them individually first, and then we'll multiply them later. So x plus 2, when x is less than negative 2, like at negative 10 or negative 5, this is all these values are going to be negative. But when x is negative 2, that's actually going to be 0, because negative 2 plus 2 is 0. Boom, there it is. And then here, when x is in between negative 2 and 3, we get 0. Like x could be 0, and 0 plus 2 is a positive number. So this is positive, and then everything after 3 is going to be also positive. So there it is, negative, 0, and then positive. Here, x minus 3 at a very negative number, like negative 100, negative 100 minus 3 is definitely going to be negative. At negative 2, it's negative 2 minus 3 is still negative. And then, but here in the middle, it's still negative, like 0 minus 3 is still negative. Everything is negative here, and then when you get to 3, it's equal to 0, and then it changes to plus over here when x is greater than 3, like 5 or 10. 10 minus 3 is 7, and that's positive. So look what happens. You've got negative, negative, positive. Negative times a negative is a positive, and 0 is bring it down. Positive times a negative is a negative, and 0, 0, bring it down. You got positives right here. Great. So what that means is we want to know, when is this inequality less than 0? Well, I'll tell you when it's less than 0. It's less than 0 here in the middle, and that's what we're going to shade in. It's not less than 0. It's actually equal to 0 here, so it does not satisfy the inequality. Leave that dot open here. Leave that dot open here, but all the numbers in between -2 and 3 are going to work. And that's that. Let's do one more. Negative x squared minus 8x minus 16 is greater than or equal to 0. Wow, there's a lot of negatives going on. So I think what I'm going to first do is multiply all the terms on both sides by -1 to produce an equivalent inequality. Remember, anytime you multiply or divide by a negative number, you have to flip the sign, and that's what I've done. And now it's just going to be a lot easier to work with. We've got so what we're going to do is we're going to say that, oh, I see this is a perfect square. This is 16, and this is x squared. So I think I can use my formula where a is going to be equal to x and b is equal to 16. You multiply 4 times x and you double it to get 8x, and therefore so we can use the formula. A squared plus 2ab plus b squared. That's just going to be a plus b squared is equal to 0. And if I wanted to, you could take the square root of both sides to solve it and get -4. And you can see here, but the factored form here is going to be helpful in the sign chart. It shows up twice, x plus 4 and x plus 4. There's only one solution, so it only divides the number line into 2 different regions, everything before -4 and everything after -4. And you can see before -4, like at -10, -10 plus 4 is -6, and that's negative. And this would be 0, and this would be positive. Well, a negative times a negative is a positive, and a positive times a positive is a positive. So so this inequality here is never negative; it's always positive. And so, what we're looking for is when is this inequality going to be? When is this particular inequality here going to be less than or equal to 0? And then we can see that it's only less than or equal to 0 here at -4. Now, if we had said, so I just added another row just to help compare what we're looking at. So x plus 4 times x plus 4, that's really this inequality right here. And you can see, when is that less than or equal to 0? It's really not on this side. It's not less than or equal to 0 on this side either. It's only less than or equal to 0 right here in the middle at -4. Now, if you wanted to compare the original inequality, which has a negative in front of it, that would be this one right here, the negative version before I multiplied. You can take all these output values, and you can make them negative, and there'll be negative and 0 and negative here. Because they were positive, you're just flipping the sign from positive to negative, and you can ask yourself, when is that greater than or equal to 0? And it's the same answer. When is it greater than or equal to 0? It's only greater than or equal to 0 here in the very middle, at -4. Now, if we had flipped that around, for example, this would have been like, here's another example that I wanted to do as well. But I think it's just we've had enough examples. If I had done this entire thing here, and instead of this symbol, I had this symbol right here, less than 0, then when is it less than 0? Well, it's less than 0 at all of these regions and all of these regions, but not in the middle. So that's just another, just to give you an idea for what it could look like. Like it can look here and look here and here. These are like vastly different ways of, even opposite different ways of shading things. Sign charts, when are they used? They're used for nonlinear inequalities and elsewhere when it comes to graphing and calculus work. So wanted to start using them earlier. And what preliminary work do you have to do? You have to put them in factored form: a x minus b times x minus c, and then some sort of inequality symbol compared to 0. I wanted to say that my favorite board game is Settlers of Catan. That's your audio check. If you ever played Settlers, let me know if you have. Let me know what your favorite board game is to play with friends. And there it is. Have a great day, and I'll see you in class.